Hey everyone, welcome back. We're going to try and give a quick 10-minute recap of what was going on in class today and a lot of things for week number 5. Also, the key terms and the quiz. Remember, the quizzes are put out there on Wednesday afternoon, and they're actually open all the way through Saturday. So make sure you're taking the online quizzes. We also have in-class assignments, but you got to make sure you're taking those and using your notes, because that will definitely be the thing that helps you most with the quiz is the things that we cover here in class. And what do we cover today? Well, we're going to start with this kind of busy looking thing right here. See that little red dot that's being buffeted around by all the blue dots? That's a representation of something called Brownian motion. And one of the things that, let me kill this right there, that we start off with is talking about molecules, atoms, the way atoms are put together. Now you go into more detail on that in high school, in 8th grade, across the hall, that sort of thing, but we definitely need a little bit of background of molecules and atoms in this class, because we talk a little bit about the chemical reactions of photosynthesis, the chemical reactions that are putting carbon dioxide in our atmosphere, for example, the shape of molecules, very, very important when we're talking about proteins. We'll get to water in just a second, the particular shape of that molecule. Well, let's run through the day and what it looked like in here. Again, keeping it to 10 minutes. One, we started with, the brain pop. Brain pop had this one fact that I really wanted to make sure that we got down, because it came up again and again in class today, and that is atoms are mostly empty space. One of the things, like if you saw football this weekend, there's some pregame football this weekend. If you think about the quarterback going back to pass and getting ready to throw a football, why doesn't he just wait there all day and wait for someone to get on open? Try to give the example, well, let's just say that you gave a quarterback a change of the rules where he could stand there with one of those medieval maces that was spinning around like this in the pocket. Of course, he can't just wait all day to throw a pass. There's a bunch of big linemen that are ready to put him into the turf. But if he had a mace and was spinning it around while he's fading back to pass, they might not be quite so anxious to go in and tackle him. Here's the point behind that silly example. If you have something spinning around really fast, like that, it can give the illusion that there's like a solid space, a solid barrier. The old-fashioned mace, it looks like a ball with a bunch of spikes coming out of it, spinning around really, really quickly. That right there is one solid object, but it's moving so quickly, it creates a barrier, creates an illusion of like a solid line around which you can't pass. The other example I gave in class was this right here from the book fair. If you can see that, it just spins really quickly. It's a bunch of lights that spin really fast. Now, they're just individual lights, but if you spin them fast enough, it gives kind of like the illusion. It gives the idea that there's something solid there. That's a little bit. Now remember, the classic example of protons, neutrons, and electrons is just a model, but that's a little bit like you can think about atoms. You've got electrons zipping around the nucleus, which is the protons and neutrons, and they're going around so quickly, it creates almost like, you can think of it like a field, an illusion of a solid thing. They always draw them in the textbooks like little solid marbles or golf balls or something like that, but they're not really looking like that. I just want you to have somewhere in the back of your mind that they don't exactly look like that. It's simply a model. Also, it's one of those things too that when we start teaching this stuff in school, when we're giving it a little bit of a background about protons, neutrons, electrons, and atoms, it's almost a little silly. I almost get a little apologetic about it. I can't say to everybody in the class, okay, now everyone pull out your atom. We're going to look at your atom under a microscope. You have no way of looking at something that small with a light microscope. As a matter of fact, we've only actually imaged atoms very, very recently. The reason I had that little thing getting bopped around on the board when I first started here, that was on the projector, I showed that to the class. I want you to look it up for yourself in the PHET simulations with your Chromebooks. That was called Brownian motion, named for a botanist named Robert Brown, who first saw that around the early 19th century. He didn't know why a little piece of pollen was getting bapped around when he was looking at it in the water. Now, pollen isn't in and of itself alive. It's part of a seed. It can, if it falls on the right flower, we're going to learn all about flowers and pollination in this class, develop into a seed. But before it does that, it's not technically alive. So what's going on? He knows that the pollen is not technically a living thing. It's in what you call it's not even a seed yet. It's not even in a dormant state at this point. Why is it moving? Didn't know. He puts that idea on a shelf, makes his observation. Remember, observation skills incredibly important in science class. Einstein comes along almost a century later. We've talked about Einstein in this class already, and says, hey, wait a second, this is something that can expand as a proof that atoms and molecules exist. In class, instead of using pollen, our analog for it, and if you'll excuse me going off screen here for a second, was a little bit of dye and water. We took some dye, and the students had glasses of water on their seats, put in 1 drop, if we could, and very, very slowly the dye was spreading throughout the water. I challenged students to think, okay, if you tried to keep the water as perfectly still as you could you keep the dye from mixing? And generally, the students had the right idea that no matter what you did, the dye was going to mix with that water. The molecules, the atoms, are always moving. They're going to move the dye around that water. Now, later on in the class, we'll come up to things like, okay, well, if you're cooking and you use, for example, lipids or fats on top of water, that stays in little bubbles. Why does that happen? That's a little bit later. That leads into some of our key terms about charge. But the long and the short of it is that because the molecules are always moving, in this example, that's a lot like the Brownian motion. Well, instead of pollen grains moving all over the water, in this case, we've got food coloring or food dye moving all over the water. And by the end of the class, we used a couple different colors. It was all spread out through the entire cup that the students had on their desks. Here are key terms for the week. Remember, every single week, and this is for the parents and the students, you're to define the key terms in your notes. We use them continually, and it's cumulative. I will be referring back to key terms from maybe week 3, week 2. Your notebook is like your own reference that you can keep going back to and say, oh, what was that key term in week 3? You'll look back on it, you've got the definition, you're good to go. We had about 15 minutes in class to work on these key terms right here, using our Chromebooks, using our dictionaries that are in class, and using our science books. I would like you to think for yourself on this one right here. Classwork, it says CW for classwork over there. What is the difference between an atom and an element? There's a slight difference in the definitions there, so I want you to be able to think about that. From there, we moved on to, and let me spin the boards here again just a second, a picture of the Brownian motion in the pollen grain. Let me see if I can get that centered best I can as I look at my screen. Now, it's not the best picture in the world, but if you look at the pollen grain being bapped around right there, it was just a random movement of the pollen grain in the water. Also, the picture of the water molecule, we're going to see this a lot over the course of the year. We've seen the Mickey Mouse molecule in here already once or twice, but note the little plus and the minus right here. Not a minor thing. We're going to be talking quite a bit about the unique properties of water in this class. In other words, when we are talking about atoms, protons, neutrons, electrons, that gives us the background to talk about something like the water molecule and why its unique shape, the way it bonds with other atoms, the way it has a positive and a negative charge. We call that polar. It's a polar molecule. Makes it absolutely unique and absolutely essential for life. The shape of that molecule makes all life on this planet possible. When we talk about kind of that lopsided look here, the Mickey Mouse molecule, we call it continually, that plus and that minus have everything to do with the way that it bonds and the way that it interacts with other atoms. And also, when we did density last week, one of the things that make water unique amongst almost every substance in the entire universe is that as it gets colder, as it freezes, it gets less dense than it is in its liquid state. In other words, ice floats. If it wasn't for that one little fact, think about our oceans on the planet. They would all freeze from the bottom up, making complicated life on this planet completely impossible, and really all life not possible. So when you're looking at the shape of the water molecule and how it ties in to learning about protons, neutrons, electrons, and elements, this is why. One of the next weeks, I believe week 6, we're going to be going into the process of photosynthesis, what atoms and what molecules are involved, and how they switch partners, how they end up making sugars and releasing oxygen into our atmosphere using sunlight and the raw ingredients of carbon dioxide and water. Probably the most important chemical reaction that we study in this class, certainly, and probably the most important chemical reaction on the whole planet. So when you're looking at that, finally we wrapped up the day with about, just 10 minutes. I just want to show a tiny bit of the Bill Nye episode where he's talking about atoms. And at the very, very end of where I got up to on that one, about 10 minutes in. He leaves off just about to talk about water, how we know the 2-to-1 ratio of hydrogen to oxygen there in water. So that's going to be what we're going to hit tomorrow in class. Hope you had a good Monday. Remember those key terms. Notes are out there online at pacificascience.org and also in your Google Classrooms. Don't forget the quizzes are posted on Wednesday afternoon, and you've got all the way through Saturday to take those. We have 2 assignments beyond those that are due in class this week. Take care. Have a great week 5, and see you online and in class. Bye-bye.